Section 210.8b5 now applies to any location where heating, air conditioning, and refrigeration, or HACR, equipment is installed. This interpretation means that outlets installed in attics for air handler maintenance must be ground fault circuit interrupter, or GFCI, protected, even though there is no direct reference to this requirement in the National Electrical Code, or NEC, itself. The primary reason for this code interpretation and application is the increased risk of electrical shock in areas where HACR equipment is commonly located. These areas often exhibit damp or wet conditions, which significantly elevate the potential for electrical hazards. Ground fault circuit interrupters are specifically designed to mitigate these risks by providing a critical safety function. When a ground fault is detected, which indicates that electrical current is flowing through an unintended path, the GFCI quickly trips the circuit, cutting off the power supply and preventing potentially lethal electrical shocks. While the NEC may not explicitly mandate GFCI protection for all outlets located in attics, the handbook serves as a valuable resource that offers critical guidance for interpreting the code's requirements. In this context, the handbook clarifies that GFCI protection is indeed required for outlets in attics specifically when HACR equipment is present. This interpretation is crucial for ensuring compliance with electrical safety standards and minimizing the risk of electrical accidents. It is essential to recognize that the handbook is not a legally binding code in itself. However, it plays a vital role in providing essential guidance on how to correctly interpret and apply the NEC regulations. Electrical contractors and installers should always consult the handbook whenever they encounter uncertainty or require clarification on how to apply the code in specific situations. This practice ensures that installations are performed safely and in accordance with the intended safety standards. The inclusion of GFCI protection for outlets serving HACR equipment in attics represents a proactive measure to enhance electrical safety in environments where the risk of electrical shock is elevated due to dampness or wet conditions. By understanding and adhering to the guidance provided in the handbook, electrical professionals can ensure compliance with the NEC and protect individuals from potential electrical hazards. Therefore, the handbook is a vital tool that assists in the correct interpretation and application of electrical codes, contributing to safer electrical installations overall. The 2005 handbook makes it clear that ground fault circuit interrupter protection is required for outlets in attics where heating, air conditioning, and refrigeration, or HACR equipment is installed. The interpretation of Section 210.8b5 as it applies to locations where HACR equipment is installed is crucial for electrical safety. Ground fault circuit interrupters, or GFCIs, are essential safety devices designed to protect individuals from electrical shock by quickly disconnecting power upon detecting a ground fault. Ground faults occur when electrical current deviates from its intended path and flows to ground, often through a person. The risk of electrical shock is significantly elevated in damp or wet environments, which are common locations for heating, air conditioning, and refrigeration, or HACR equipment. While the NEC does not explicitly require GFCI protection for all attic outlets, the handbook's guidance clarifies the necessity of GFCI protection for outlets serving HACR equipment in attics. The handbook serves as a crucial interpretive tool, providing insights into the code's intent and application in specific scenarios. Contractors and installers should always consult the handbook when facing uncertainty about code interpretation, ensuring compliance with safety standards. The handbook is not a substitute for the NEC, but it serves as a valuable resource for understanding and applying the code correctly. The handbook's guidance on GFCI protection for HACR equipment in attics aligns with the broader goal of enhancing electrical safety in potentially hazardous environments. By adhering to the handbook's recommendations, electrical professionals contribute to the prevention of electrical accidents and injuries. Therefore, a thorough understanding of the NEC and the handbook's guidance is essential for ensuring safe and compliant electrical installations. It is important to note that the NEC is updated regularly to reflect advancements in technology and safety practices. Staying current with the latest edition of the NEC and related resources is crucial for electrical professionals. The NEC provides comprehensive requirements for electrical installations, covering a wide range of topics beyond GFCI protection. These requirements are designed to ensure the safety of people and property from electrical hazards. In addition to the NEC and the handbook, other resources such as manufacturers' instructions and industry standards can provide valuable information for electrical installations. A comprehensive approach to electrical safety involves considering all relevant codes, standards, and guidelines. Proper installation and maintenance of electrical equipment are also essential for preventing electrical hazards. Regular inspections and testing can help identify potential problems before they lead to accidents. Electrical safety is a shared responsibility involving electrical professionals, homeowners, and building owners. By working together, we can create safer electrical environments for everyone. This section of the code emphasizes the importance of ground fault protection in specific environments, especially when dealing with equipment that can introduce moisture or other conductive elements into the vicinity of electrical components. Understanding the scope and intent of this regulation is vital for ensuring safe electrical installations. When we talk about the 2005 handbook, its role is primarily interpretative. It's designed to provide clarity and context to the often dense and technical language of the NEC. The handbook isn't a substitute for the code itself, but it offers explanations, examples, and illustrations that can help clarify the intent behind the regulations. In the context of Section 210.8b5, the handbook's explanation regarding heating, air conditioning, and refrigeration, or HACR, equipment is particularly relevant. It highlights that the requirement for GFCI protection extends to any location where such equipment is installed, not just those explicitly mentioned in the codebook itself. This is a critical point because HACR equipment often operates in environments where moisture or condensation is present, increasing the risk of electrical shock. GFCI protection is designed to mitigate this risk by quickly interrupting the electrical circuit when it detects a ground fault. A ground fault occurs when electricity strays from its intended path and flows through an unintended conductor, such as a person. GFCIs are highly sensitive and can detect even small ground faults, tripping the circuit within milliseconds to prevent serious injury or death. The rationale behind extending GFCI protection to locations with HACR equipment is rooted in the inherent risks associated with these environments. Condensation, leaks, or spills can create conductive pathways that increase the likelihood of electrical shock. By requiring GFCI protection, the code aims to reduce the risk of electrocution for anyone who might come into contact with electrical components in these areas, especially during maintenance or repair activities. It's also important to recognize that electrical codes and standards are constantly evolving to address new technologies, materials, and safety concerns. The NEC is updated on a regular cycle to reflect these changes, and it's crucial for electrical professionals to stay informed about the latest revisions. The handbook also undergoes revisions to align with the latest code changes and provide updated interpretations and guidance. In addition to the NEC and the handbook, there are other resources that can be helpful for understanding and applying electrical codes. These include training courses, industry publications, and online forums where electrical professionals can share their knowledge and experiences. By utilizing all available resources and staying informed about the latest developments in the field, electrical professionals can ensure that their installations are safe, compliant, and up to code. This is especially important in areas with unique environmental conditions, such as coastal regions or areas with high humidity. In these locations, the risk of corrosion and moisture-related electrical problems is higher, making it even more critical to follow best practices for electrical safety. In summary, the requirement for GFCI protection in locations with HACR equipment is a crucial safety measure that aims to reduce the risk of electrical shock in potentially hazardous environments. By understanding the intent behind this regulation and utilizing available resources for guidance, electrical professionals can ensure that their installations are safe, compliant, and protect the well-being of those who use and maintain them.